Hello, welcome to part 19, Wolves on the BackBit. Document everything. This one phrase kind of became my mantra for a while because, well, at the end of the last part, I had a great idea for compressing the color. Yes, I have talked about compressing the color over and over, but this particular idea was like inspiration from the heavens. It was like, wow. I couldn't believe it had pretty much everything that I'm looking for in a routine. All I can remember is it was elegant, it was clever, it was fast, and oh man, I was so itching to try it. I don't know if it would have worked, but the fact is, I forgot what it was. And it wasn't a dream. It was like I was ready to do it. And then, things happen and you didn't do it. And that's where this episode begins with me just, beating myself up about this because, well, I didn't do it. And it's not the end of the world here. It's just another stupid routine, a few bytes shuffled around to create a code, to create a routine, but I was it's kind of like throwing your Christmas present into the garbage before you open it. It's like, what could it have been? But anyway, yes, document everything. So you'll see from the clips here, I kind of get a little carried away. And it wasn't until after watching the little restaurant clip that I realized this isn't really healthy because I've been there before. I've done that particular segment of code. I am reinventing the wheel that I already reinvented. So it kind of taught me another thing. Realize where you're heading and wrap it up because, well, duh, I'm making these videos now. That is pretty much as wrapped up as I'm going to get, right? But yet, even though I'm still making the videos, you'd be surprised how many times I've revised the program in the slightest way since. So yeah, there's a bit more to come after I'm, quote, finished, but not a lot. But yeah, I learned a bunch of stuff and a few, last minute things that really made my day. You'll see. It is, well, you'll see in the last episode. I'm quite pleased with how it turned out. But let's see, what else can I tell you? Oh yeah, well, what's the rest of this episode? I tinker with different memory cards. I've been using the same memory card for this entire project. So on a whim, because I didn't want to, wreck my good card, I put in a different card. And that card sucked. It had a worse access times. And of course, can of worms time. Let's find an even worse card. Oh yes, and see what you can do to screw that up. So I learned more things, which hopefully helps you down the road as well. So let's get to it. Part 19. Document everything. Got your pen in hand? Nah, you won't need it. Just watch. I have a way to deal with the color, and I'm going to show you that probably right now. Did I say now? I meant more than a month from now, because a month has already passed. There's my stuff. There's my desk. Commodore's packed up. I'm waiting to get the keys to my new place. Because it has air conditioning, because look how stupid hot it is in here. This place sucks. Yeah, I'm running out of things to do here. Good thing I got the PS4 hooked up, but the color, whatever I just promised that would happen, quote, now, is I forgot. It helps to document everything you do. Because the idea was in my head, but it was not on paper. It's kind of like Fermat's last theorem. It might be lost to the ages, but I'm sure I'll give it enough thought and come up with something similar, if not the exact same damn code that I had planned in the first place. Document everything. Well, September 9th, 2022. 6:30 in the morning, that's not the point.
I don't have my Commodore hooked up. It's somewhere in there. Wow, what a mess. Anyway, I don't have a new idea to compress the color yet, but what I do have is an idea I came up with yesterday, of which I'm going to explain real quick now. The 211, 227 idea, where the 85s or the zeros are transferred to 85s. You have, sorry, I just woke up. You have a series of flags that are in the last page of the bitmap, which are accessed first. 31 values that you throw onto the stack, and you pull them one at a time. And as you pull for each page, it'll either be a 0 or a non-zero, or possibly a non-zero and or a negative value. But it is a flag to either do the ordinary breakdown for that, oh boy, ordinary breakdown for that bitmap page without fancy compression stuff, or if savings can be had, do the check for 227 on every single cell for that page only. So the delay does not apply to the entire screen, just for the 256 bytes of the bitmap, where the overall savings will be better for doing the compare and the skips or whatever versus not. Does that make sense? I hope it does. It does enough to me, so in the future I can go back and go, oh yeah, that's what I meant to do.
Document everything. Now, if in every group of 8 of the color, you load it, and if it's 0, you skip all of it. That's 128 groups of 8 bytes each, but a cost of 2 cycles if the entire screen is busy and you don't skip anything. But if something is skippable, well, first of all, 125 times 2 is 250. It costs 9,000 cycles to color the whole screen. So it's 3% slower. That's the cost, just to have the overhead, whether you use it or not. But the payback, if you can find 4 sections of 8 skippable colors in one frame, it pays for itself. Everything beyond that is gravy, because you load it with 4, you skip it with 3, that's a cost of 7. Normally 9 times 8, 72, minus 7, 65, times 4, well, 260. So 260 is greater than 250, and anything beyond that is extra speed. But then again, the 0 can also be a different flag, whether it can...
Well, the old Commodore is hooked up again at the new place. Trying to get my bearings here. Look at this. Look at the times. 92%, right? I switched memory cards. I was using this one. You can't even see it. Whatever. It is a Kingston Canvas Select something something. I can't really read the speed. It's a good one. But I was going to do some experimenting, so I put in a junk card with files on it. And this junk card has a slower read speed. So what I can hope for is, in the end, get 100% with my good card. Junk card, well, screw it, right? It's interesting, though, that it's that much slower. I might see if I can secure myself an even faster reading card. Maybe I can cheat my way to 100% without having to lift a finger. Oh, yeah, and it is October 22nd, 2022. So I've been at this for over a year. Obviously, in the last however many months, I've done almost nothing. But, well, I've said it before. I hope to get this done soon. Let's see if I can stick to it.
It pretty. But I could never. Shimmery.
Yeah, I'm having fun screwing around. I completely put in a mega long delay in the main generic copy routine just for fun, because I'm trying to get it to freeze before it turns black, because, well, it doesn't have 935 frames. In this case, 937 represents the total number of displayed frames plus the number of skipped frames. So at some point, it counted to 10, called it a skip frame, counted to 10, called it a skip frame, and eventually it got to check, hey, am I done? Oh, I'm totally done, and then it leaves. But in that case, 2 extra frames got skipped beyond the end of the file, which, don't exist. So the total frame number is always a fudge. But the final frame that you've been seeing for so many times is a 0 frame that I stuck in the file, a 64K buffer space between the video and audio data. So it plays that, usually, almost always, and then it drops to basic. So I just wanted to put in a big-ass delay to cause it to freeze before that point. When digging in my random memory card box, I found this old 1 gigabyte micro SD, and I'm going to hang on to it because I have, I'm getting pretty slow reads from it. And the only thing I did a complete fresh format from Windows. I threw on my latest working copy of the BBT. The delays are interesting. While I'm definitely not going to consider this my goal to make this flawless play. As it is, I am now prepared to give up, and with a little more effort, I'm gonna stop at whatever percent I end up with, because I mean this has gone on too long. I have other things to get onto, but this card is good to hang on to because whatever project I'm working on, if it's BackBit intensive, using a junk card like this is a good way to tax it. It's kind of like how demo coders supposedly want to write their stuff to work on the most misaligned 1541 they can find. I'm glad I have the skipped frame code in place because it works very well. I like it. And I mean, there is a point when you can overwhelm the thing. If things are super slow, the audio will trip over itself. You can't skip audio. Audio will just stutter, whatever. But video, there is a way to skip the frames, and I'm very proud of that. This is the ultimate tax. I'm using that 1 gigabyte slow card. I've set the audio read to a low byte of 1 versus 0, so it's not on the even page. That slows it down. And I set the video pointer to a low byte of 8 compared to 0, which also slows it down. And obviously it's screwing stuff up, but at least it's a value of 8, so it doesn't corrupt bitmap cells. I'm just looking at it. I want to see how slow this gets. I'm running one of my finaler versions, which writes the color back sequentially and writes the bitmap cells, or the generic routine also reads sequentially. Because I got to prepare myself for a possible bitmap skip cell routine. Best case, I get 90% playback on my regular player with these changes versus 93 if generic just goes wild and the color just doesn't do it sequentially either. I did experiment with putting the NMI into 0 page, but I forgot there's other portions of that routine that expect it to be in a certain high byte, and too much work to save 1 cycle per interrupt. So I decided to leave it where it is because, yeah, I was going to overwrite this stuff just enough, and I found out when you're done and you go back, even if you hit stop restore, it does not put this back. You need a full machine reboot or save this on your way in and put it back on your way out. But anyway, that's just something I learned. It's not worth the trouble. All right, so let's see how slow this is. Ah, yes. Oh man. The thing is, when you get a 0, it's because the delay got so low that it stopped and it wrapped. That's why these are 0s, and these pretty slow, but not terribly slow. Changing the audio and the video on my bad SD card, the lowest byte delay, not delay, the Q. It's usually 0, which is the fastest way to do it because it's even page. But changing them, I had this at 1, and that made this complete zeros, which means the timer completely expired. I changed it to 8. Well, apparently 8 is easier to find than a 1, so it's faster. The video, I had at 8, and we had a decent number, but at 3, it's choking. Interesting, eh? So it doesn't like odd numbers, and I don't know if it's the SD card's fault or the way the BackBit itself works, but it expects happy, dividable by whatever values. So by throwing at these curveballs, I'm getting some interesting readings on what actually makes it choke. Now, that was pretty interesting, wasn't it? Just to see, because remember I said when you queue up BackBit data to an even page, it's fast. So in this case, I not only did the page, I did the middle byte. So it's forced to only advance into the next 64K chunk. So that's the fastest that I believe is possible with this terrible SD card. I'm going to try it with my good card next. And that's why the audio repeated as much as, it kept repeating itself and wouldn't change. Like it would play the buffer over and over until the reader or whatever in the file advanced 64 kilobytes. And then it would start fetching from a different place to fill the buffer. Same thing with the video. And since the video isn't lined up in juicy 64K sections, it gets out of sync with what's proper, and then you end up just getting garbage. But interesting stuff. Now, let's see if I can get if my good card gets better readings than it used to with page alignment. I'm not saying I'm going to switch, but it'll be interesting to see because I know both the audio and the video get about 5,000 each. The audio is slightly slower on my good card. I've noticed that now that I'm paying more attention to it because the audio is farther down in the file. Anyway, let's switch to my good card and put in the same simple tweaks and see what happens. All right, well, this is the usual test. Don't forget, my usual 93% is now 90 because in this case, generic is going sequentially for all purposes, which it doesn't need to. The color during the frame refresh is doing sequentially instead of like 16, 32, 22. So this is better for just general purpose stuff. But anyway, that's not the point. So the way I've been doing it lately, these are my access times, right? Now, I will switch it to aligned. Well, this is aligned to every 256 bytes. Now let's align it to every 64K. But before we do that, let's switch the low byte to 3 and 7, just to screw with it. Of course, the audio has no problem staying on track, but it doesn't take much to screw the video up. Wow. This is definitely a surprise, isn't it? Oh, yeah. Not much else to say, except now I'm definitely curious to see what 255 does. But yeah, well, it'll still work in a pinch, because I mean, this is like a 40th of a second. Big deal. But because of it, I'm dropping more frames, right? So, duh, it doesn't need to be that way, and there's no real purpose to it except seeing how the BackBit works. Let's switch these both to 255. Well, it's not as bad as I expected, but I am confused because why is the video longer to queue up than the audio? The video happens first in the file, so I'm not exactly sure what this means, because I mean, let's go check it out. See there, I'm directly starting. The first digit is FF, followed by getting Y and doing whatever Y is, and then Y again and whatever Y is. And for the video, you see, I'm just directly doing the FF and then whatever and whatever. So yeah, whatever, exactly whatever. I might fudge with this some more, but let's get to it and put the 64K in place. Well, here, I'll show you exactly how to do this first one. Switch that to 0. Simple as this. Now it's basically ignoring everything. The only time it's going to make a difference is when Y changes, like video mem +2. So, well, get rid of that. Assemble. All right. Yeah. Okay, I'll see you in 2.5 minutes. Well, that's not too impressive. We're pretty much back to what happens when you're doing it exactly to the page. I don't know what happened at the beginning here. What's with the 7,000? But, you know, we're dealing with, like, stuff beyond simple, predictable cycle stuff that you can do on a Commodore. Like disk read speeds and stuff. Who knows? There's a million reasons why this could be out, and it's not my problem. But yeah, now this is probably the best I could ever hope for. I mean, if I wanted to, I could try it with a low byte of 1, of 2, of 3, of 4, of 5, and graph them all out, and then I'd probably see this, and I ain't gonna do that. I gotta just, I'm curious, but I'm not, I got only so much time, right? Good enough. So I'm going to put it back to the even page, and I'll do some more tweaks another day, because it is now, well, it's almost 2 a.m. and it's time for bed. I'm tired. Ciao, ciao. Now, just on a whim, well, you've already read the note there. I'll show you what it means. There. This doesn't do anything. This doesn't do anything. This DEDO, oh man, my photo doesn't make sense. But DED0 only expects a parameter, this one. The first one you feed it, and then you cap it with a BB, and then pound the DO. It knows to queue up in extended memory whatever 0 to 255 times 64 kilobytes that you've specified. So it's not a 24-bit address. Well, it is a 24-bit address, but it already knows inside that that's 0 and that's 0. I don't even have to tell it. And I thought maybe that would speed it up even further. It does not, but that's okay. I wasn't going to do this. I just wanted to see if you could get something really fast by obeying a 64K boundary, especially doing it this way, the DED0, the BackBit instructions. That's the shortcut to just use a 64 kilobyte offset. Did make a difference. All right. It's still almost 2 o'clock. Oh, yeah, I was supposed to go to bed. Okay, done.